this is Chapter 1, Lesson 7, Computing with Scientific Notation. So in the last lesson we talked about scientific notation and moving things from standard form into scientific notation and back again. So it makes it a little bit easier when you're solving things. So now we're going to talk about when we add, subtract, multiply, and divide using scientific notation. So the first thing I have is multiplication and division with scientific notation. You can use the blank, 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 and blank, blank, blank properties to multiply and divide numbers written in scientific notation. So in those blanks, you're going to write power of powers and quotient of powers. Okay? So use power of powers and quotient of powers. So you can use either of those properties to multiply and divide numbers written in scientific notation. So the first thing that we want to do is let's look at a problem. Number 1 says evaluate 7.2 times 10 to the third times 1.6 times 10 to the fourth. We can express our result in scientific notation. So what they want us to do is first look at just the numbers, the 7.2 and the 1.6. I want to go ahead and multiply those first. 7.2 times 1.6 gives us 11.52. Then I want to deal with the exponents. So I 10 to the third times 10 to the fourth. Okay, and using the power of powers rule, it tells me that all I need to do is add those exponents together. 3 plus 4 gives me 7. So now I have 11.52 times 10 to the 7th. Well, we know 11.52 is not in scientific notation. Remember, our scientific notation numbers have to be between 1 and 10. 11 is not between 1 and 10, it's greater than 10. So what I need to do is I need to change it into scientific notation, which means I needed to move this decimal point over 1, which means I need to add 1 more to my exponent value. So my final answer is 1.152 times 10 to the 8th. All right, let's go ahead and look at problem number 2. Problem number 2 says in 2010, the world population was about 6,860,000,000. The population of the United States was about 3 times 10 to the 8th. About how many times larger is the world population than the population of the United States? So the first thing that we want to do is we're dealing with really large numbers here. So we're dealing with scientific notation. We want to change that 6 billion into a number that's more easily manageable. So we want to change that, we want to estimate it. So when we do that, when we estimate that, we round up to about 7 billion. Okay? So when we've done that, when I change 7 billion into scientific notation, I've moved my decimal over 9 times. So I have 7 times 10 to the 9th power. Now, I was asked how many times larger is the world population than the population of the United States. So here's the world population. Here's the population of the U.S. and we're dividing. So I'm taking 7 times 10 to the 9th divided by 3 times 10 to the 8th. So again, I can just divide my whole numbers and then I can deal with my exponents. So 7 divided by 3 is approximately 2.3. 10 to the 9th divided by 10 to the 8th. Okay, remember I can use my quotient of powers rule. Exponents, I subtract 9 minus 8 gives me 1. So my final answer is 2.3 times 10 to the first power. So the population of the world is about 23 times larger than the population of the United States. And how I got 23 is when I change this back into standard form, I just move my decimal over 1 spot, so I get 23. So it's about 23 times larger. All right, there are a couple of try-it problems. I want you to go ahead, pause the video, try out the try-it problems, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try-it problems, let's go over the answers together. So the first one I have is letter A. Letter A states 8.4 times 10 squared times 2.5 times 10 to the 6th. So what I want to do first is I want to multiply my whole numbers together. Okay, so 8.4 times 2.5. Okay, when I do that, that gives me 21. Okay. Then I want to focus on my exponents. I have 10 squared times 10 to the 6th. Well, I can use my power of powers here, so I just have to add the exponents, which is 2 plus 6, so I get 10 to the 8th. Now, 21 isn't written as a scientific notation number. I can't use 21 because it's not between 1 and 10. So I need to move a decimal over, so I need to add 1 to my 8. So my final answer is going to be 2.1 times 10 to the 9th power. All right, for letter B, I have 2.63 times 10 to the 4th times 1.2 times 10 to the negative 3rd. So again, the first thing I want to do is I want to look at my numbers that are in front of my powers of 10. So I'm going to multiply 2.63 times 1.2. That will give me 3.156. This is in scientific notation. Okay, so that's great. Now I need to focus on my powers of 10. Here's a power of 10, here's a power of 10. So that's 10 to the 4th times 10 to the negative 3rd. So I can just add these together. 4 plus negative 3 gives me 1. So it's 10 to the 1st power. So my final answer when I combine all of this together is 3.156 times 10 to the 1st power. All right, letter C says the surface area of Lake Superior, the largest of the Great Lakes, is 8 times 10 to the 4th square kilometers. The surface area of the smallest Great Lake, Ontario, is 18,160 square kilometers. How many times as great is the area covered by Lake Superior than Lake Ontario? All right, so my first Great Lake, Lake Superior, use blue for, and then Lake Ontario, use purple. So I want to do 8 times 10 to the 4th. So when I set this up, I want to go ahead and set it up. Okay. Over, and then I want to change 18,160 into scientific notation. So when I do this, I move my decimal 1, 2, 3, 4 times. So I get 1.816 times 10 to the 4th. Okay. So then again, I want to go ahead and divide my whole numbers. So I divide 8 divided by 1.816. That's my first step. Okay, that will give me 4.405. That's great because that's already in scientific notation terms. Okay, then I'm going to have 10 to the 4th, 10 to the 4th. So when I divide those, this is really saying 10 to the 4th minus 4, because I can subtract my exponents according to the quotient of powers property. So this is really 10 to the 0 power, which is really just 1, because anything raised to the 0 power is 1. So my final answer is going to be 4.405. So it's 4.405 times as great. All right, the second part of this is dealing with addition and subtraction. So we just dealt with multiplication and division. Now we're going to deal with addition and subtraction when we're computing scientific notation. So in the box up here, I have addition and subtraction with scientific notation. When adding or subtracting decimals in standard form, it is necessary to line up the place values. In scientific notation, the place value is represented by the blank. Before adding or subtracting, both numbers must be expressed in the same form. So in that one, you're going to write exponent. So in scientific notation, the place value is represented by the exponent. So before we add or subtract, both numbers must be expressed in the same form, which means they both need to be in scientific notation and they need to have the same exponent value. If they don't have the same exponent value, then we can't actually subtract them or add them together. So I'm going to go ahead and look at an example. I have number 3 here first. It says evaluate each expression. Express the result in scientific notation. So the first one I have is 6.89 times 10 to the 4th plus 9.24 times 10 to the 5th. So when I'm doing this, you can see that 10 to the 4th and 10 to the 5th are not the same. 5 is bigger than 4. So I want to go ahead and change this, the 10 to the 5th, to 10 to the 4th. In order to do that, I move my decimal one place over. So now 9.24 becomes 92.4, and my exponent value decreases by 1. So now they're the same, and I can add them together. I just go ahead and add like I normally would for decimals. I add 6.89 plus 92.4. Now when I do this, quick reminder, I have 92.4 plus 6.89. You need to line up the decimals. You can add zeros if you need to. So 9 plus 0 gives me 9. 8 and 4 gives me 12. Bring down my decimal point. 6 and 2 is 8 plus 1 is 9. And 9 plus 0 is 9. So I get 99.29. And then my exponent just tags along, times 10 to the 4th. So my final answer, then I need to change it back into scientific notation. So 99 is bigger than 10. I have to move my decimal one place back and add my exponent. Okay, so I get 9.929 times 10 to the 5th. All right, my next one is number 4, 7.83 times 10 to the 8th minus 11,610,000. Now, 11,610,000 is not in scientific notation, so we need to put it into scientific notation. So when I do that, I need to move my decimal 7 times. So I get 1.161 times 10 to the 7th. Okay? Notice that 10 to the 8th and 10 to the 7th are two different exponents, which means I need to simplify this one from 8 to a 7. So I need to move my decimal over. So I get 78.3 times 10 to the 7th minus 1.161 times 10 to the 7th. I subtract my numbers. 78.3 minus 1.161. That gives me 77.139 times 10 to the 7th. Then I need to turn it back into scientific notation. 77 is still too large. It needs to be between 1 and 10. So I get 7.7139 times 10 to the 8th. Number 5, I do the same way. 593,000 needs to be changed into and scientific notation. I change it into 5.93 times 10 to the 5th. So now I'm adding 10 to the 5th and 10 to the 6th. Okay? It doesn't matter which one you change into scientific notation. It doesn't matter which exponent you make larger or smaller. It's completely up to you. In this instance, they actually changed the 10 to the 5th and made it 10 to the 6th. So they just had to move the decimal. Okay, so they moved the decimal over, so that's 0.593 times 10 to the 6th. Whichever way works for you, if you want to change it to the smaller one, if you want to change it to the bigger one, it will still give you the same answer in the end. Okay? When I add these together, 0.593 plus 7.89 gives me 8.483 times 10 to the 6th power. In this case, for number 5, because they made this a larger exponent, they actually kind of eliminated a step for them. At the end, they didn't have to change it back to scientific notation. So there are 3 try-it problems on this page. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try-it problems, let's go over the answers together. So on this page, we have letters D, E, and F. So we're going to start with letter D. Letter D says 8.41 times 10 to the third plus 9.71 times 10 to the fourth. I need to change one of these into either a larger or a smaller exponent. So the first one I want to do is I want to go ahead and change 8.41 into a larger exponent. So 8.41 times 10 to the third, I move my decimal over 1, so I get 0.841 times 10 to the fourth. Okay, now I just add my decimals together, 0.841 plus 9.71, which will give me 10.551. That's not in scientific notation. I need to move my decimal over 1. So I get 1.0551 times 10 to the fifth power. Okay. Letter E says 1.263 times 10 to the fifth minus 1.525 times 10 to the seventh. So I want to go ahead and change one of these so that it's larger or smaller. I'm going to go ahead and make this one smaller. So 1.525 times 10 to the 7th. I want to move my decimal 2 places. Okay, so this gives me 152.5 times 10 to the 5th. Now I can subtract. Make sure you do it in order. 1.263 minus 152.5. And that will give me negative 151.237. Then I need to change times 10 to the 5th. Okay. I need to change it back to scientific notation, so I move my decimal 2 spots. So this gives me negative 1.51237 times 10 to the 7th power. All right, the last problem, letter F, is 6.3 times 10 to the 5th plus 2,700,000. So I need to change 2,700,000 so it is in scientific notation. So I move 1, 2, 3, 4, 5, 6. So I get 2.7 times 10 to the 6th power. So I need to change one of these or both of them so that they have the same exponent. I'm going to go ahead and change 6.3. So 6.3 times 10 to the 5th, I'm going to move and change. So it's 0.63 times 10 to the 6th power. Now I add my decimals together. 0.63 plus 2.7 gives me 3.33, okay? And then I just add my exponent. So I get 3.33 times 10 to the 6th. And that is the end of Chapter 1, Lesson 7.